Alrighty, you guys, we're going to go ahead and look at uh, lesson 1.4. We're basically talking about sketching rational functions, okay? And here's the different things that we're looking for. Let's just kind of read over each one of these, right? So the first thing is our domain, okay? Now, for right now, the questions that we're looking at are all going to be, well, not all, but mostly, like not this one, are going to be rational functions, okay? For rational functions, what we're basically looking at is bottom cannot equal 0, all right? That's 0 denominated. And then the other thing is square rooting negative numbers, okay? We can't do those two things, all right? Okay, perfect. Next, vertical asymptotes. This is basically once we get the reduced function, so we cross out the stuff. Once we get the reduced function, its denominators cannot equal 0 from the reduced function. Okay. Okay, holes. We've talked about holes quite a bit. This time we're not using the reduced function, we're using the original function. Okay. And basically, I think you guys know this, but this is where we already have 0 over 0 or top and bottom cross out. That's where we get holes, right? Okay, next, x-intercepts. It says let y equals 0. Well, that's true. So what we're doing, you guys, is we're letting like this whole thing equal 0. Now, here's the thing. I'll write it on this side. A fraction will equal 0 when the top equals 0. That's it. So that's what I remember for x-intercepts, okay? So I just remember that that is where top equals 0. Y-intercepts are where we let x equal 0 and solve for y. So I'm going to just go ahead here and write plug in 0, okay? And then end behavior. This is really important. All right. Look at the highest degree terms in the numerator denominator and analyze for large positive negative x values. Okay, you guys, end behavior. We're looking the limit as x goes to infinity and the limit as x goes to negative infinity. And remember that we had those three rules. Top bigger than bottom, bottom bigger than top. All right, and that's how we do end behavior. Okay, and then our last one, like whether it's an even or odd function, kind of symmetry it has. This one is kind of like, might help you, but anyways, just check and see if the asymptotes, the x-intercepts, or the holes have like a pattern to them, and that might help. Okay? All right, so let's just take an example of some of these. Give the domain, reduce it, vertical asymptotes, holes, and behavior. Okay, here's how we reduce this, guys. We go ahead and factor it out. Nothing crosses out, okay? Let's go through our stuff. Our domain, all real numbers except x, not b, 2. That, you guys, come back off, right? Now, since nothing crosses off, those are my vertical asymptotes. Okay? My end behavior, all right, let's check this out. Limit as x goes to infinity. I'm going to go back to this. Okay, check it out. The degree of the bottom is bigger than the degree of the top, 2 and 1. Right? So my end behavior is it goes to 0. So the limit as I approach infinity goes to 0. And then what I should write, excuse me, is I have a horizontal asymptote at y. Okay? Those are kind of the different things that we are looking for. By the way, this is an odd asymptote, which means like along the line. Oh, actually, wait, no, that's not what I was looking at. I meant to say the vertical ones. The vertical ones are odd asymptotes along the lines. So like one side goes up, the other side goes down. Okay? You know that because it's not like square. All right, cool. Look at this next one here. My domain is all real numbers except x not -3. My vertical asymptote is at -3. This happens to be an even vertical asymptote. I can calculate squared. And so what happens is it goes same direction. Okay? Up, up, or down, down, or something. All right, let's go ahead and look at our end behavior. So the limit as x goes to infinity of this, I'm just going to go ahead and multiply it out. Well, it's x squared plus, and then the rest does not really matter, honestly. It's x squared plus 6x plus 9. That doesn't really matter. So if we look at this, top is bigger than the bottom, and if I plug in positive infinity, it goes to positive infinity. Okay, so this doesn't have a horizontal asymptote. It probably has what we call a slant asymptote. But I'll check the other one for end behavior. As I go to negative infinity, right? Top is still bigger than the bottom, so I know it goes to infinity. But on the top, infinity to the third, or sorry, a negative to the third is negative. A negative squared is positive. So this just goes to negative infinity. So that's my end behavior. Okay. Positive infinity goes to positive infinity, negative on this one. All right. Number 3. So it was all factored out here for us. That was very nice. My domain comes from those. X cannot be -2. X cannot be 2. Otherwise, it's all real numbers. All right. My reduced function, that's what this R equals. My reduced function is x plus 4 over 2. Now this tells me, because I crossed off x minus 2, that when x equals 2, I get, so that's at x equals 2. Now, what we're going to start getting used to, though, is writing that as a coordinate point. It's 2 something. So where exactly is the hole at 2, 1? Well, you guys, that's where we go. What's the limit as x approaches 2? And now that I cross that off, I can plug in 2. And I get 6 over 4 or 3 halves. 1.5, whatever. That's my hole. Okay? Now, this part that's on the bottom right here, that's my asymptote. So I have a vertical asymptote at x equals -2. That's why I want to put my hole as a coordinate point, by the way, is the asymptote is like an x, so it's like an actual line. All right? My end behavior, I'll just go ahead and get it from right up here. So it's x squared plus 2x minus 8. Oops. Over x squared minus 4. As I plug in, well, actually, as I look at this, the degree of the top and the degree of the bottom are equal. So that goes to 1. The same is actually true as I go to negative infinity. As I look at that, they're equal. It doesn't matter if I put a negative in there, and negative squared is positive, and negative squared is positive. That also goes to 1. So the end behavior, they both go to 1, and I have an asymptote at y. Okay? All right. Cool, cool. So let's look at a couple of examples here, you guys. If the domain, reduce it. Oftentimes you must factor before you can reduce. Find vertical asymptotes and holes, x and y intercepts, end behavior, symmetry, that's optional. If needed, find a starting point in the graph. All right, so here we go. The domain of this first one, you guys, all real numbers. There's no square roots, fractions, there's no dividing by zeros. It's all real numbers, okay? My x-intercepts are when y equals 0. So if I set this equal to 0, I have zeros at, well, let's see, here, here, and here. 0. I add that over 1. I add that over 2. Oh, I'm sorry, that's a plus. -2. Okay. 0, 1, -2. So the way I'd write these is 0, 1, 0, -2, 0. Here's the other thing, you guys, and you'll remember this from last year from pre-calc, okay, is with our zeros, you guys remember what happens when I have a squared right here? So if it's a single, like to the first, it crosses the x-axis. But if it's squared, it bounces. You guys remember that? Okay, so I've got a cross, and I've got a bounce. All right, my y-intercept is when I plug in 0. So if I plug in 0 right here, I'm going to get 0 times -1 times 2 squared, which is just 0. Which is fine, I already have that point there. Okay, but end behavior is really important. It goes like this. If I find the limit as x goes to infinity of my function, okay? Now you guys, let me just go ahead and write this out. That's x to the first, x to the first, x squared. It's x to the fourth, and a bunch of other stuff, right? To make it a fraction, I can put that that's over 1. So the top is clearly bigger than the bottom, so it goes to positive or negative infinity, and infinity to the fourth is positive infinity. If I do the limit as x goes to negative infinity of x to the fourth and all this other nonsense, right? A negative to the fourth is also positive infinity. What that means is that my arrows go like that, okay? So my end behavior is like we can put up, but really, like if we're being exact, it's the limit as x goes to infinity is infinity and negative infinity, okay? And then I just kind of put this all together and I sketch it. It's going to bounce on there, and then it's going to cross, and I'm chilling. We graphed stuff like that last year, but now we're doing it with calculus concept, okay? All right, sweet. A couple more. This is a very good, very classic question. I can almost guarantee something like this will be on your chapter test. Okay? All right, we start off by stating the domain. Now, right here, so it's all real numbers, but x can't be 0. Right here, it can't be 1, and right here, it can't be 3. Now, can it not be because those are asymptotes or wholes? We don't know yet. They're one or the other. It just can't be any of those 3 things. So here's what we do. We reduce this, okay? All right, one of the x's cancel out. One of those cancels out. And none of those cancel out, okay? All right, now here's the thing. I'm going to go ahead and write my vertical asymptotes next. My vertical asymptotes are at x equals 0 and x equals 3, okay? So let's go look at what I crossed off of here. I crossed off a 0, or I crossed off the, 0 over 0, but that's an asymptote. And I crossed off that. So if I go back and look at my domain, it can't be 0, 1, or 3. 0 and 3 are asymptotes. What's 1? Well, you guys, when I cross it off the top and bottom, that is now a hole. Now, because of the point, though, we want to write it in x equals 1 as a coordinate point. So let me go ahead and plug 1 in here. I get 1 minus 1, 4 to the third over 1 and negative 2 squared. So it's 0 over whatever. So my hole is at the point 1 comma 0. Okay? So far, let's just kind of put what I have here. Okay, I have an asymptote at 0. Oh, I need that to be bigger. I have an asymptote at 3. I have a hole at the point 1, 0. Oh, too big. Okay? All right, x-intercepts. We're going to take the reduced part and set the top equal to 0. So it looks like for my x-intercepts, I should have intercepts at x equals 1 and x equals negative 3. Now at x equals 1, I already know there's a hole. So I can't count as an intercept, it's a hole. But at negative 3, I have an intercept. So I can write that as the point negative 0. So that gives me like a point. Okay, if I do my y-intercept, so I plug in 0, we'll just go into the reduced one. If I plug in 0, you end up getting like 27, so it's like negative 27 over 0 times 9. Well, that's going to be undefined, so there are no y-intercepts. Okay, and then last but not least, our end behavior. This is limits to infinity. Maybe I'll just go, sometimes I just like to go back to the original equation. Okay, check it out. I have x squared, x to the third, that's 1, 2, 3, 4, and then a bunch of other crap. Okay, here I have x squared, x squared, so it's 1, 2, 3, 4, 5. Okay, because the top is bigger than the bottom, it's going to go to infinity. Now look, as I go to positive infinity, a positive over a positive will go to positive. That tells me that I have something that goes like, I don't know, up that way somehow. As I go toward negative infinity, it still goes to infinity, but because a negative to the sixth is positive, a negative to this negative, it goes to negative. It's like down like that. Okay? Interesting. I have no idea. Here's my best guess. You ready? This crosses through. It has to go down and then has to go up. So it goes, I'm guessing something like that. I have no clue what's going on the other side. This goes like this. And then you guys, it can't cross because if it did, I'd have an x-intercept there. It can't cross. I'm thinking it goes like that or something. And then through the middle, I don't really know exactly how it goes. I could plug in a point to see. So like, for example, if I plug in a 2, I get 1 times 5 to the third over 2 times -1. So I get a big negative number. So I don't know, my guess is that it goes like that. Okay, so now let's see how right I am. Okay, so it kind of went down there, through there, had a 0 like that. If I'm close at all, boom, boom. Ooh, so close. Now I made this a little bit more extreme in terms of like going straight down and it goes kind of over. So I guess, I don't know, I made that go straight down. I guess it should go more like that. Still going off to negative infinity though. Okay. And then yeah, my middle part comes through. Well, I must have plugged in 2 wrong. This is telling me it comes through this way. I guess makes more sense. And then my last part goes like that. All right. Kind of a tricky one to graph, but there you go. Weird, weird. Okay. Let's see if we can graph this last one. Whew. All right, here we go. Domain. X cannot be 0 because the bottom can't be 0. But then the square root of x squared is okay because like it's like the part that's inside can never be negative, while an x squared can never be negative anyway. So that's my only domain right there. Okay, vertical asymptote is when the bottom equals 0, so I'm thinking it's at 0. Okay, so let's go and put a vertical asymptote there. All right, and then I've got no holes. X-intercept is when the top equals 0, so that's the point -1, 0. That's there. Y-intercept is when I plug in 0. And I get 1 over 0, so there's none. And then, okay, end behavior. This is going to be interesting. Okay, so we know the square root of x squared kind of acts like x. That's going to go to 1. So I have a, what's it called? I have a horizontal asymptote at 1. Okay, now here's the thing. We've done things like this before. The limit as x goes to negative infinity of this, it's also 1, but here's what happens, okay? A negative infinity on the top is negative. A negative infinity squared is positive, so that actually goes to -1. Now, Nothing happens in the middle. Those are horizontal asymptotes. Don't worry about what's happening in the middle. It's just what's happening at the end. So what this is saying is like, as I go to positive infinity, it's going to approach 1. I don't really know from where. And as I go to negative infinity, it's going to approach negative. Okay? That's kind of interesting. I don't know. So that's my end behavior. So I have a horizontal asymptote at 1 and negative 1. And then starting point, just because like, what the heck is going on here, right? I can just plug in a couple of points. I could plug in like, I don't know, -2. Give me -0.5. -3 would give me like -2/3. Okay. This kind of looks like it's going like that. And then that's a vertical asymptote like that, maybe. And then, let's see on this side, 1 gives me 2. 2 gives me 1.5. 3 gives me 1.3. And it goes like maybe like that. That's my best guess. Let's take a look. Let's go. Look at me. That's approaching -1. That's approaching +1. That's exactly what I got. Let's go. All right, perfect. Here's what you guys are going to do for homework. Just do what it asks. So domain whole vertical asymptotes, domain asymptote. Curve sketching recipes, so just use all the different stuff. And then it's just back to review. Limits. Discontinuities. I think we can do all that. Okay? I think we are good. All right, you guys, so then just do that assignment. Oh, actually, if you have a video for homework, I guess we're doing that in class. Thursday, maybe. Okay? And then we'll review or finish out the chapter, and then we'll have a test next week. All right. Awesome job, guys. See ya.